So thanks everyone for joining. My name is Nathan Piccini. I am one of the marketing managers here at Data Science Dojo, and I am joined today by Karol, and I am going to mispronounce your name even though you just told me how to pronounce it. It is Karol Pristalski, and he is the CTO and founder of Codet. He's going to be taking us through some JavaScript for cancer prevention through early detection, and you just heard us talking a little bit about the device that he has with him, and I know he's going to be incorporating that in his presentation as well. So, Karol, why don't you go ahead, introduce yourself maybe a little bit more than what I just did, and go ahead and get started.
Sure. Thank you for the introduction, Nathan. Let me just share my screen and show you some slides. All right. I will just not have slides today. I will talk about JavaScript and actually how to use JavaScript together with machine learning to beat cancer. And obviously, as you see, JavaScript is not, as you know, JavaScript is not the best language to actually build machine learning models. So about myself, well, I do machine learning and medical diagnosis in skin cancer specifically for more or less 15 years now. So I started in 2007, 2008 when I actually started IBM, working at IBM. I mean, I did it as a PhD, as a part of my studies, PhD studies, but it wasn't at the same time when I actually started my job at working at IBM. You can find some papers on the topic that are actually available on Google Scholar, for example. That's something that you can easily find. You can also find some of my lectures, some of my talks about skin cancer, how to use machine learning to figure it out. I'm not a medical doctor, to be clear. I'm a computer scientist. I'm specializing in artificial intelligence, machine learning. And one of the talk that actually I gave last year is actually published as a TEDx talk. Actually, it is in Polish because I'm actually now streaming from Krakow, from Poland. So it is in Polish, but I hope maybe the next TEDx talk will be in English. And actually, it is about skin cancer. So just to warm up, well, skin cancer, why this topic? First of all, it is a big issue globally. I mean, skin cancer. I mean, there are different type of skin cancers. Melanoma is one of it. It's the most dangerous one because if it's not found in the early stage, it's very dangerous for our health because it can actually end with death. Because it's the cancer is very progressive. It's very malignant, and especially because just to give you a medical introduction to the topic, we have six phototypes of skin. So, for example, if you are blonde, you have white skin, if you in blue eyes, and if you go outside and you become red instead of brown, I mean your skin, then you're on the first phototype, the one that actually is the most where actually the probability of getting a skin cancer of melanoma specifically is quite high. Just to mention one more thing, if you want to ask any question, you can use the Q&A part tab in Zoom. Also, if you can use the chat, if the answer is short, I will just answer immediately. If it's a bit longer, I will just keep it to the end of after the presentation. So we have six phototypes. One is the white skin, blonde hairs, blue eyes, and you get red. Your skin gets red when you actually are on the beach, and not brown. So the darker the skin is, the probability of getting a skin of melanoma is lower. So there are different kind of skin cancers. Melanoma is one of it that actually is the most popular of malignant skin cancer because it's the most deadliest one. But there are also some other malignant skin cancers, for example, that are white. I mean, maybe not white, transparent, let's say. So they are even more dangerous because it's very even harder to find such a mole that is transparent or color of the skin, more or less. So that's why actually most of the dermatologists also focus on melanoma to finding this one, because it's just very specific. There are some specific patterns that tell us, okay, that's a cancer. But that's just a short introduction about the cancer. So why actually use machine learning together with JavaScript, right? So how to combine that? I would like to show you where we can use JavaScript. It's not that I am a JavaScript engineer. I used to work with JavaScript. Actually, the web pages were written with, were created with tables. So it was many years ago. Now JavaScript is totally different. You have TypeScript, you have ES5, ES6, and all of the new standards of JavaScript. So it's a more convenient way now to really develop with JavaScript. But actually, the programming language that I use on a daily basis is still Python. I mean, it's all the time Python, because it's just more convenient to build the models. So why JavaScript? I will show you that in just a few minutes, and I will also give you a better understanding of the skin cancer. Not about the phototypes only, but how to what actually we are looking for. So let's say we have this device that is used. This is the dermatoscope that I showed you at the beginning. That's a dermatoscope. I mean, it's an extension to a iPhone. There's an extension like this lens here. That's this is actually very important, because this is actually allow us to take a picture or take a look on the mole. And this is a device that is used by the dermatologist. There are different types of dermatoscopes. This is one of the smallest one. There are big one like whole computer with a kind of something like looks like a gun. Quite big one that the dermatologists also use. That's well, let's say our pocket version of the dermatoscope. And then I will also show you, in the meantime, I would like to show you some demos, some code samples in Python, in JavaScript, to show you the differences, and then where to go next with the project, with where I'm going next with the project that I have built. All right. So as I mentioned before, I'm focused on the research on skin cancer for the last 15 years. This is a quite big problem globally, especially in the US, UK, Australia, and Scandinavia. All the countries actually, the people are there are many people with blonde hairs and blue eyes, because this is actually where the risk is the highest. Myself, even I don't look like a blonde guy, but still I have some cases in my family regarding melanoma. Hopefully, I mean, in my case, in the case of my family, everything went well, because it was the mole was actually cut on early stage, and this is how actually it works, right? If you find it on an early stage, you are healthy. There is no risk of actually, getting other type of cancers in your body, because this is how actually melanoma works. If it raises the vessels, it just spreads into your body, and this is very dangerous, because you will get cancer everywhere. But if you cut it on an early stage, it doesn't spread, so it's you are fine. So what I also did, we have signed a partnership with different kind of dermatoscope and actually all dermatologist companies to build some machine learning models. What is more, now when it comes to the analysis of skin cancer, when I started the research 15 years ago, I had a data set of around 57 images of malignant cases and not. That's not a huge data set to really do any kind of research, right? But it was 15 years ago. In the meantime, I have built our data set, my own data set of about 5,000 images. Now you have if you want to do it for non-commercial use, you can download the ISIC archive. There are also some challenges that are related to this data set that they give. You can easily download it. Everyone here can download it. It's around more than 25,000 of images of different kind of skin illnesses, not only melanoma. And that's very interesting because this is a data set that you can really start working on. I mean, use it for some real research. With 57 images, there is not too much you can really do. So because of that, it's worth now to do any kind of research in this topic. And if you look on the papers, there are now plenty of papers doing research on melanoma with higher and higher accuracy, sensitivity, specificity, and even the models that I have built for my PhD thesis. I achieve with the models higher accuracy, higher quality metrics than the typical dermatologist. So that's a different kind of research when it comes to the way how we do that. How the dermatologists find out if it's a cancer or not. But that's something that I will show you in just a few minutes when I will show us some pictures how it looks like. If you want to use JavaScript with machine learning, I have built a Docker image for you. It's quite old, but it's still valid. There is a JavaScript kernel for Jupyter Notebook and all of the JavaScript libraries that I also have here as Jupyter Notebooks on GitHub that you can use easily. So feel free to download it, run your environment based on this Docker image. It has the most important, I think, in my opinion, JavaScript libraries for machine learning. So how I started this research, I started with using different because as you can see, this device, it's an extension kit to an iPhone. So it's easier to build an application that you use a model on an iPhone using JavaScript instead of Python. I mean, technically, it might be doable to write a Python application for iPhone, but actually, it's much easier to actually use JavaScript because you can use, for example, now actually React Native is the most popular solution for that. In the past, I used also PhoneGap, I used Cordova, and XReact, and some other frameworks and libraries to actually make this application available for this mobile for my mobile phone. That's actually an iPhone 6s, so it's quite old, but still working well for skin cancer recognition. And obviously, for the models, I'm using TensorFlow.js. Well, why TensorFlow.js and not other framework? That's a very important question to set. What kind of libraries you should use, or what actually you should not use when you work with JavaScript. So why JavaScript? One of the reasons is clear. That's because you can easily build an application to use the model, and because TensorFlow is written in such a way that actually you can use the models in Python, but also in JavaScript, also in Java and some other languages, because the code is actually written in C++, and then you have also some libraries that actually use that, but actually libraries written in different languages, like Python is the most popular, but you also have it written in JavaScript. And what is important to mention here, that actually it is robust. I mean, TensorFlow.js is robust compared to other libraries. I'm talking about JavaScript now only, right? Because in Python, we have plenty of libraries that are well designed, well implemented, and are robust, and you can easily use it in production. So anyway, what I also have, what is also the advantage of using JavaScript for machine learning is that actually you can use it easily for web applications, right? So if you for example, want to move from your mobile app to your web app using, for example, your camera. I mean, it doesn't make sense for skin cancer, right? But because of you don't have this kind of lenses on your camera on your laptop, but if it doesn't actually, if it's a model that doesn't use this kind of a lenses, this kind of a topic, you can easily move it to a web app and use it also there. So how did it look in production? This is a very, very the general, let's say, very high level way how it might be used. Really, there are two ways. One of it is actually where actually you use this model as a part of the app. So you have an app that is actually a JavaScript app, and you have also a model that's loaded, and you can easily use it. Or what you can do, you can also use a TensorFlow service. Well, I don't want to go too deep into details. I know that MLOps as a topic is quite popular now, and it's become more and more popular. But actually, the TensorFlow service serving actually the model is easier to do it with TensorFlow, in my opinion. So you can actually have more apps that actually will send the image to the servers and actually do the evaluation on the server. It depends on the internet connection, so that's the disadvantage of this kind of a solution. In my case, I have both. So what I do the evaluation on the first evaluation on the app, and if the doctor wants to compare to different ones, like, oh, I see it's suspicious, right? So if you want to compare, I can also compare it using the web service, the TensorFlow service, and actually try to compare with other ones and get a more precise explanation of the prediction. Okay, so let me show you a demo. Here we go. When Flutter, Flutter is not JavaScript. So I think that's not the topic for the talk today. I hope you can see my screen now again. So I did this workshop a couple of 3 years ago when I visited Kharkiv. Kharkiv is the city in the east part of Ukraine, and I did a comparison of the libraries and available libraries in JavaScript and Python. You can easily find this notebook on one of my GitHub repositories. What is important here, obviously, in the way how machine learning training works, that's here explained. But what is important is just to go through the libraries you actually can use in JavaScript. And actually, since then, since I gave this talk a couple of years ago, not so many. There were not so many changes, really, when it comes to the JavaScript world and machine learning. So when it comes to data manipulation, if you ask a data scientist or machine learning engineer, they will tell you, okay, there is only one library for that, and it's called pandas, right? There is a library also in JavaScript that is called pandas.js. Really, here, as you can see, and you have series, you have data frames, so you can easily work with a huge number of data also in JavaScript. But it's not, well, for some basic operations, I think it's worth considering this as a library to do that. But it still lacks of many functions that actually the original pandas, the Python pandas, does have. So that's something that you should consider. That actually that's not ideal, the best solution. But if you are forced to use JavaScript for actually doing some basic data analysis, then probably you will choose pandas.js, or maybe data frame JS. There is Recline, Data Forge as well. There are some links here, you can test it out, but you can see you can easily work for series like here. The output here, if you compare it to Python, it's different. In Python, it's in my opinion done in a, let's say, more user-friendly way compared to JavaScript. Or you can work with a data frame. Here's an example how to actually work with data frames. You can convert it easily to JSON. That's actually easier, I think, compared to Python, to the Python version, or to string. You can easily work, do some filtering on data frames. So some basic functions are there. Still, it's still limited. So probably, if you're not forced to actually use JavaScript, you probably use the original pandas. Still, the pandas in JavaScript is not yet such robust. I mean, in general, when you compare the libraries in JavaScript and Python and see the numbers, so in JavaScript you have more libraries for machine learning than in Python. But the thing is that if you take a look on the robustness or how good the libraries are, then the Python are obviously even less. They are just better compared to JavaScript ones, because there are plenty of libraries in JS that just doesn't work or are not yet are not maintained now, or someone did something. I mean, develop a small method and then just is doing nothing with it. And if you, for example, compare it to scikit-learn, that's a huge difference, because everything is, I mean, when it comes to not shallow methods, everything is scikit-learn. When it comes to visualization, I think JavaScript has disadvantages that just done a bit better compared to Python. Probably some of you might disagree with me because you have matplotlib, you have Cber, and some other libraries. But in my opinion, it was in my work it was a bit easier to use JavaScript. I mean, the JavaScript libraries for drawing charts are more convenient to use using, I don't know, D3, for example, React-Viz, Recharts, and there are plenty of other libraries that you can use for drawing in JS. When it comes to the machine learning and the shallow methods, right? So you have a port, or let's say library that should work like scikit-learn that I mentioned before, but there are two that I mentioned here, the JS kit learn and scikit-learn in JS, but both are not maintained anymore. I mean, one of it's actually the last update was 1 year ago, and the second was 5 years ago. So, well, it's not worth to risk using it. The most robust library is obviously TensorFlow.js. So I guess you know how TensorFlow works. We have the tensors and the flow, the connections here. That's obviously the linear regression explained here. So you have the graphs, and this is how you import the TensorFlow.js and work on that. So yeah, you have also the same for Java, Go, and other languages, also JavaScript. So the back, actually, the kernel here is same for all of the libraries. So that's good, because it only depends on the low-level API, right? That's actually implementing what's in the kernel in the specific language. So that's how you use it in. Also, as you can see, because we have let, also ES6 that you can use for that. All right, here's the implementation of the linear regression, right? Easy implementation with some examples of a training data set. Here's also the gradient boosting, right? So optimizer, SGD with some learning rate. That's easy also to implement in JavaScript. Right. When it comes to the Keras, I mean, I know that now Keras and TensorFlow it's not the same. We cannot tell it's the same, but they cooperate well, and you can use Keras and TensorFlow and other way around. So that's not really possible in JavaScript. I mean, there is something like that called Keras.js, but still, I mean, you can load the model like here. There's a bin file, so you can build something in Keras and Python and actually use it in JavaScript. But building models in Keras.js, it's not it's not the thing you want to do on daily basis, because it's not so convenient, it's not so easy to do. Yeah, some of my details here clear. What next do I have here? Let's just go back to, yeah, that's the same with Python, right? The data frames, if you want to compare how to work, you see the output is a bit better. Some visualization using the matplotlib, or the one library that is actually used with data frames. So you can see it's a bit easier to manipulate, but still when it comes to the ways how to visualize, it's a bit easier to in JavaScript. Datasets also available in scikit-learn that you can use directly to test your models, like here the linear regression decision tree, and obviously TensorFlow as an example in Keras, just to compare between these two. All right, so let me show you some images of, here we go, skin cancer. That's now you can see 3 moles, skin moles. If I would ask you which of these, if let's say from the left you have mole number 1, number 2, and number 3, which of the one here is a skin cancer? So probably, I don't know, you would say, I don't know, 1, right? Or maybe, I don't know, maybe 2, because it's, it has some this kind of a different kind of net here, or maybe the one on the right. Actually, the number 1 and number 3 are melanomas. Melanomas confirmed by the histopathology test. So there are cancer cells, because both, I mean, all 3 moles were cut off and checked on the microscope to check if there are moles. I mean, if there are cancer cells. So number 1 and number 3 are. You don't know that, but I know that because I'm working on melanoma for about 15 years now. I can see some patterns here that are specific for melanoma. The one on the right here, that's an obvious pattern. You can see here, it's kind of a structure that looks like gray, blue-white structure here, this one here. This means that the advantage of the advance, I mean, how advanced is the cancer, is it's quite high. I mean, it already reached the vessels, right? So it means it's an advanced stage of the cancer because of this color here. So this means, okay, you need to cut it off and actually really do some serious treatment, just not to get because you are not dying because of skin cancer directly, but because of what comes next. So different kind of cancers in every part of your body. So this is an advanced cancer. Here on the left, you can see there are some stripes and some. You see the dots here, right? The dots. This mole is also not regular. It's asymmetric, not regular. The borders are not well. I mean, they are not smooth. It's more sharpened. So that's also some. These are actually the patterns that are also specific for melanoma. So the dots, you can see it's going deep. Here, the stripes here, right? It's also something that is specific for, there's a pattern that tells us, oh, that's a melanoma. Also the vessels here around, that's also a pattern that tells us, oh, that's something dangerous. Not always, but that's something that should, let's say, you should think about it if it's really something dangerous or not, if there are this kind of vessels here surrounding. So the 3-4 patterns that I just mentioned here are specific for melanoma, and actually it is a melanoma. The one in the middle, even the net inside, it is not a melanoma. This one is quite, I mean, it's not super symmetric, but not so bad compared to this one or this one. We have different colors. In melanoma analysis, we have 6 colors, right? So we have skin color, light brown, dark brown, blue, and red. So you can see here we have a few colors, some nets, but that's only suspicious. So how do doctors do that? How do doctors do that? They use different kind of wavelengths of light, or different kind of scoring methods. I mean, both actually. In the typical scoring method like ABCD or 7-point scoring method, 3-point scoring method, they use just a typical wavelength of light, just a visible light. So they only see let's say the first level of the skin. In Hunter's code, they use different kind of wavelengths of light, so they also see what's also visible in the other cells inside of the skin. Each of these use different kind of patterns. Like ABCD stands for asymmetric, border, color, and differential structure, or diameter, depending on that, on what kind of paper you're looking for. 7-point score is based on 7 patterns. Overall, we have more than 30 different patterns that are specific for melanoma. So you can imagine for the medical doctor how difficult it is to really to know all the patterns and find them on the picture. Here's an example where actually images where different kind of wavelengths of light are used. You can see here infrared. You can see the cell, the vessels here, right? In both cases, it's bad because you can see there are too many of them, too many inside, and here you can see a lack of vessels. And here it's this collagen that you can see, the collagen in the skin, and you can see some white dots here in this image. That's also not good because this is how deep this mole actually goes inside your body. So what I did, or what many people do during the research, there are 2 types of let's say researches that are done. One of it is actually using some image processing methods, trying to extract the mole and find some patterns based on that, like here on the binary image, or they just use some deep neural network to find the patterns, or actually not patterns, because patterns that's something that will come. What the research are now focused on on finding different illnesses like melanoma, right? And for example, in the ISIC, you have, I guess, 7 or 8 classes, so 7 or 8 illnesses that you can find. But this is only just a few, but only illnesses, not the patterns. So the next step or the next stage would be to find the patterns, not the illness itself, to give let's say, to support the dermatologist to find, oh, there's a pattern that you need to take a look. And that's actually where the research is now going. Here you can see, if you take a look, it's not smooth. I mean, the border, right? But still, it's not so bad how it could be. So let me show you some examples. Here we go. I guess it's here we go. So border, for example. So what usually people do, they remove the border, right? Here's an example from the ISC archive, just to get only, I mean, because the images are like that. So what you do to just cut the background. It depends on what kind of dermatoscope you use, because some of them are flat like here. So if you take it like that, so it's strict, connects with the skin, then there is no issue like you can have here with the dark outside. Still, there might be some light from the outside if you are looking on something that is not really on a flat. If the skin is not totally flat, like I don't know, if you put it, I don't know, here, for example, you cannot put it directly to the skin. So there is also some light coming from the outside. So that's the first challenge that many researchers approach or actually work on. The other thing is about actually removing the hairs. That's also very a big challenge now, because it's not easy to remove the hairs. So extracting regions that are regions of interest, more actually images. I know if you eat breakfast, that's not the first thing that you want to see, but this is how actually skin cancer look like in the zoom, obviously. So it's usually between 20 and 50 times zoom, together with a polarized light to get structure inside. You can see here it's a very small one, and if you extract it, you can get actually something like that. So we just take the most important part of the model out of it. So that's the next step. What you do next, you can also calculate the sharpness or asymmetry of the model. Here you can see there are different ways how to do that. I know it's written in Python, and you probably expect to have it in JavaScript, but no, the model I develop in Python, but I use it using JavaScript. So there's some binarization here, and we just extract the border and try to find the border sharpness, like here, right? Depending obviously on the parameters we set, we can measure the border sharpness, right? So that's another thing. Yeah, asymmetry checking. I didn't show that. So how usually researchers, I mean the dermatologists do, they divide the image into 8 different regions and try to find the asymmetries and actually get the numbers out of it. How actually symmetric is the mole, or the blue veil, for example. That's the most typical pattern. So that's not. I mean, you can use it. You can actually not. You don't need to use any, sophisticated neural network to find it out, because it's the color is very clear, because you just extract the blue value. In our case, we have found the threshold. Here's actually, we use also some neural network for that, but it's not something that you actually need to do for that, because finding a threshold is enough to find this one. That's here, this color is the blue veil, or blue white veil, blue gray veil. It depends on the book you are reading about this pattern. All right. So what is also very important is to also, because why I'm talking about also the neural networks is that, well, finding cancer, it's a medical topic, and trying to build a model that is will be accepted by the FDA, you need to make it explainable. What it means, well, if you have, for example, a typical neural network like here, we have 1, 2, 3 layers, 3 layers here, easy to train, high accuracy, 98%, with just a few epochs easily. But if you try to explain that, it might be hard, because if you print the weights from one layer only, it's something like that. So trying to explain all of the weights, it's not possible. The deeper the network is, the less possible it is to actually explain that. So usually you can do what you do to make an explainable method. I mean, to build a model that is explainable, is to use our white box model method, like here. That's a decision tree. Can be easily drawn, and actually it can be converted to some switch or if statements, easy one. Or you can try to explain the neural network using, for example, the grad cams, right? That's another thing that you can do. All right, I think I'm running out of time, so let me just go back shortly to the slides. This is how actually the first POC looked like. So a patient, example of patient, take a photo, and actually the ABC patterns were actually checked, where actually it was found. Now, because I cannot show you the current version, because it's actually will be used by one of the dermatoscope company, it's much more advantage, because we show exactly where the pattern is and how it looks like. So what are the pros? Using JavaScript, easy for prototyping, especially this kind of a solution where actually you have some hardware that actually need to work with some mobile phone. You have a support. I mean, there's a huge community of JavaScript community. So and actually JavaScript is not a language that is hard to learn. It's because of the React Native solution. They work with plenty of different models of mobile phone models, so you can easily move it to different kind of easily use it on different many phones, also on Android if you want to. So that's good, and obviously can be easily moved to the web app. What is not so good, well, when it comes to JavaScript, there is not such a good support when it comes to MLOps. So actually moving into production, it's quite hard. Even the community, JavaScript community is huge. There is not such a big community when it comes to the machine learning topics related to JavaScript, and many of the libraries are obsolete or deprecated, or well, not robust enough to really use it in production. That's all when it comes to the presentation. So I'm now ready to answer your question. I see some questions already here in the Q&A section. Have you guys, okay, one question here. Have you guys tried using cannabis research to help mitigate this problem or help it heal, reverse it? You mean the cancer? Healing the cancer with cannabis? Well, I would recommend that. I mean, I'm not a medical doctor, so I think that's more like not a question to a medical doctor. But I think well, that's not the right way. How you, I mean, I heard about cannabis to be used to as a painkiller solution, but not as a solution to beat cancer, especially melanoma, which is a very progressive, very malignant cancer. That's actually even the current. I mean, now it's much better than, let's say, 10 years ago. But even if you actually take some drugs, many drugs are just not good enough to really beat this cancer. That's why we have so many deaths when it comes to melanoma. So I would recommend that, but again, I'm not a doctor to recommend the treatment. I think there are better persons to do that than me. All right. Any more questions? Or any other questions?
I'm not seeing any others, but maybe people are typing them out. So maybe I can talk about our next week's webinars and we can see if any more questions pop up. And then, sure. Perfect. So next week, and maybe I should just share my screen. That might make things easier. All right, so next week we have 2 webinars. On May 31st, it's Between the Spreadsheets, Classifying and Fixing Dirty Data for Data Science with Susan Walsh, who is the founder and managing director of the Classification Guru. So, I mean, we all know, and Karol can probably tell you this also, real world data is never clean. There's always some issue with it. So Susan's gonna, walk us through that and show us how to fix that, if possible. And then on June 1st at 11 a.m. Pacific, so an hour before the previous day, it's R and Python, the best of both worlds with, and I'm sorry, Boyan, I'm going to butcher your last name too, Boyan Angelov, I think. I hope that's how I pronounce his name. So he's the Chief Technology Officer at, I'm going to say that's VAM or VAAM. And he's just kind of taking us through more than just the pros and cons of R and Python both, but he's saying, the argument between which language is better is over. And he's going to take us through, how do we use, how to use R for this, how to use Python for that, what are the differences between the two, and which is the best for your scenario. And Karol uses Python. So yeah, so that's what we have going on next week. I hope you can see that. Karol, can you see that screen?
I can see your screen. Okay,
perfect. So I hope to see you all next week. I'm not seeing any other questions, so I think we can end here. So thank you, Karol, so much. We'll have your recording up and available either later today or early tomorrow, and we'll make sure to send that to everyone as well. Thank you everyone for joining, whether it was in Zoom or on our live stream. We really appreciate having you. And if you're interested in any of our data science programs, we do have an information session tomorrow. I believe it's at 9 a.m. feel free to drop in and learn about what we do at Data Science Dojo. If I don't see you there, I hope to see you at our webinars next week. So thank you, Karol. Thank you, everyone. And I hope you all have a great rest of your day.
Thank you very much. Thank you. Bye-bye.